work in exactly 2 minutes. Okay, so let us start our work. What I will do is I will show you my screen, and good morning, no afternoon. Okay, so let us start our work. So here I go to the first slide. Last class I was explaining to you about anode rays, cathode rays, and I explained to you that all this happened around 1900 when people just discovered an electron. So there was an evacuated tube experiment. So based on that evacuated tube experiment, they found out specific particles called electrons. Yeah, over the next 3-4 years, they found another particle also. They found this another particle called the proton. How was the proton formed? Proton found. Proton was also found by some kind of a bombarding experiment. So before we go to the other bombarding experiment, let us go to a model of an atom which is known as Rutherford's model of an atom. So the first model of an atom was given by J.J. Thompson. J.J. Thompson, after finding or discovering an electron, what he did is he gave a model which is called the Plum pudding model. So this is what I explained to you in the last class. According to this model, any atom consists of a basic structure, basic substrate. They called it the substrate. Substrate means basic matter like payasam. In this payasam is positively charged. In this payasam, there were embedded negatively charged. So that is nothing but the plum. In our case, it is basically the kishmish or draksha. Okay, so this was the first model of an atom. Nobody liked this particular model of an atom, but J.J. Thompson's student Rutherford did a few experiments which we will call the gold foil experiment. Okay, so what Rutherford did is he took a gold foil. He took a gold foil and he bombarded the gold foil with alpha particles. Okay, he bombarded the gold foil with alpha particles. Yeah. Now, what are alpha particles? Alpha particles are nothing but helium nucleus. Now, these are particles which came from radioactive material. Around 1904, there was a scientist by the name Becquerel. Becquerel. Becquerel specimen of radium to all her friends. One of her friend was becquerel. So from that radium, radium is radioactive. So from that becquerel was able to discover radioactivity. Okay, can't hear me. Yeah, yeah, I will show you. Actually, there is a power cut here, so I don't know how it is going to work out. There is a power cut, and then we are trying to. It's okay now. Okay, so okay. So I hope all of you it is clear now. But there is a power cut, so I don't know how long things will work. There was heavy rains yesterday. Yeah. I will show you. I will show you. Okay, fine. Okay, let me continue till it works. When it doesn't work, there's nothing we can do. So Marie Curie discovered radium. After she discovered radium, she gave some samples to her friends. One of her friends was becquerel. So becquerel was able to find out there are something called as alpha particles. Alpha particles are positively charged. Okay, they are nothing but helium. Helium has two protons, two neutrons, and two electrons. So if you remove the two electrons from helium, what you get is an alpha particle. So he took a gold foil, Rutherford took a gold foil, and he threw hundreds and thousands and millions of alpha particles at it. Okay, so what is his idea? Because gold is highly malleable and ductile. Malleable and ductile. Okay, because gold is malleable and ductile, it can be drawn into very thin sheets. Thin sheets. So what he expected is, if this is the sheet, there will be one atom of gold here, one atom of gold here. There will be only few atoms of gold. So he took a very thin sheet, as thin as it was possible. And then when he fired the alpha particles, he said, now my alpha particle is going to go and interact with the atom. Okay. So now based on this, what happened is that his first observation is that most of the alpha particles pass through without any deviation or disturbance. Basically, I am seeing a wall in front of me, and on the wall I throw hundreds of balls, and all the balls pass through the walls. Yeah, all the balls pass through the wall. So what will it mean? Yeah, what will it mean? So it will mean that the wall is completely hollow. There is no wall. So this is the first slide where I was telling about J.J. Thompson's plum pudding model. We learned this in the last class. Then this is the second slide where I'm now telling you about Rutherford's model of an atom. This is also known as the planetary model of an atom. So this is an experiment conducted by Rutherford where he took gold foil and he bombarded it with alpha particles. Alpha particles are positively charged in helium nucleus. So he took alpha particles and he bombarded. When he bombarded, most of the alpha particles passed through without any deviation or disturbance. His inference was that most of the space of an atom is empty. Most of the space of an atom is empty. Okay, it is most of the space of the atom of an atom is empty. That's what he could infer. The second one is a few of the alpha particles got deviated. A few of the alpha particles got deviated by small angles. By small angles. What do you mean by small angles? So suppose this is the gold foil. Suppose this is the gold foil. Most of them passed like this. There was no problem. Without any deviation, most of them passed this way. Then very few of them, they went like by small angle. This angle here is small. So they got deflected by a small angle. Very few of them got deflected by small angle. Yeah. Now, when does a positively charged particle get deviated? Only when it meets another positive charge, because we know positive will repel. Yeah, because positive will repel. Only if it meets another positive charge will there be a problem. So what we could infer from this is that there is a positively charged particle inside the nucleus. Yeah, there is a positively charged inference. There is a positively charged body inside the nucleus, inside the atom. Okay, this positively charged body, they called it the nucleus. Yeah, a few of the alpha particles got deviated by small angles. So you may draw this diagram and then understand that most of them pass through without any repulsion or any problem. A few of them got deviated by small angles. Inference that there is a positively charged body inside the atom. Okay, there is a positively charged body inside the atom. This positively charged body inside the atom is called the nucleus. This positively charged atom inside the body is called nucleus. Yeah, then there was a third inference, third observation, that very few particles nearly 1 in a million, nearly 1 in a million were reflected back. Reflected back means they went this way and then they came back. Yeah, very few of them, 1 in a million reflected back. Now, what is the inference that you can draw? That the positively charged center is extremely small. The positively charged center is extremely small. Okay, is extremely small. Not just that, it is also very heavy. It is very heavy and probably contains the entire mass of the atom. Okay, so this is the inference. So there were 3 prime observations. One, most of the alpha particles went straight without any deviation. Second, few of them got deflected at small angles. The third, very few particles, nearly 1 in a million, were reflected back. Okay, so these were the 3 observations. So I hope you have made notes. I'm also dictating. Please listen to me. I am also dictating. I will write bigger, no problem, but please also listen to me. Yeah, I will show you the slides at the last. Don't worry about my notes. I'm also dictating. I'm also speaking. Please listen to that. Okay. Yeah. So I am saying that point number 1 is most of the alpha particles passed without any deviation, as if nothing was there, indicating that majority of the space of an atom is empty. Okay. Then the second point is that very few of them, very few of them, but few of them were reflected at small angles. They got deflected at small angles, yeah, indicating that there is a positively charged body inside the atom. The third one is very few particles were reflected back. So when they were reflected back, the meaning is that this positively charged center is extremely small. Meaning of bombarded. Bombarded means thrown with at a very fast rate. Okay, my teacher bombarded me with questions. As soon as I went back home after the holidays, my friends bombarded me with their stories. Yeah, so bombarded means thrown at, given, told. Okay, so in this case it is thrown at. So they bombarded me I mean, I should not say, but suppose that okay, in this case bombarded means fired at. Okay, so fired at means you are throwing many alpha particles at the yeah, clear. Okay, good. Yes, so fired at, correct. Okay, okay, so I'm going slow, very slow. Okay, so the second, let us go to these inferences. So please make notes of these inferences. So the first one, I told you that most of the alpha particles, most of the space in an atom is empty. The third one, a few of the alpha particles got deviated by small angles. What do you mean by small angles? They were going like this, they were going this way, they were going this way, they went this way. They were going this way, they were going this way, they went this way. They were going this way, they went this way. Slightly they got deviated. This angle, theta, this angle is very small. Angle is very small, very small. How small? Like 1 degrees, less than 1 degrees. Okay, indicating that there is something positive which is kind of pushing it towards the other side. Then the third one is very few alpha particles, nearly 1 in a million, were reflected back. The positively charged center is extremely small. That is the inference. Then it is very heavy and probably contains the entire mass of the atom. Look, if I throw a ball at a few stones, so when I strike the carom board with the striker, when the striker hits the coins, both of them move in the same direction. Why do both of them move in the same direction? Because the striker is heavier than the coins. Now, sometimes when a coin hits a striker, it comes back because it is lighter. So in the same way, but when I hit the coin very fast, both will again move in the same direction. So same way, what happens is that the fact that the alpha particles are returning back indicate that the nucleus is very heavy. If the nucleus was not heavy, it would not have got reflected back. Okay, the positively charged center is extremely small. It is very heavy and probably contains the entire mass of the atom. So this was the third inference. Okay, now based on this, he came up with his model called the planetary model of an atom. Based on this, we have Rutherford's planetary model of an atom. Yeah, based on this, we have Rutherford's planetary model of an atom. Okay, now the salient features of his model. One, the nucleus is at the center of the atom, just like the sun. Okay, just as you have the sun at the just as you have the sun at the center of the solar system, the same way the nucleus is the center of the atom. Yeah, then this nucleus contains all the positive charge and mass of an atom. This nucleus contains all the positive charge and mass of the atom. I hope we are able to understand this. Yeah, 1 minute, I'll be back. Yeah, voice not clear. Okay, or is it the head of the atom? It is the head of the atom. No head. Rutherford is like a sun. Nucleus is the brain of the atom. Yeah. Okay, Dominic, some problem at your end, Dominic. Otherwise, the others won't be able to hear me. Okay, if there's a problem at my end, no, others won't be able to hear. Okay, so please check. There will be some problem. But anyway, the recordings will be there. You will get it. If not, you ask me again, I will teach. Okay, so this nucleus contains all the positive charge and mass of the atom. Then the third point is that the electrons revolve around the sun just as the planets revolve around the around the nucleus, around the sun. The next point is the planets revolve around the nucleus the electrons revolve around the nucleus just as the planets revolve around the sun. Because of this, it is called the planetary model of an atom. It is called Rutherford's planetary model of an atom, like a planet. He says the atom is like a planet with the sun as the center of the solar system. The same way, the nucleus is the center of the atom, and the electrons will revolve around it in circular loops or in circular paths. Okay, so if you understand this, electrons revolve around the proton and neutrons. Yes, not any W, it is any U. Okay, so once this is done, then there is some point here that we need to know. The centripetal force required for the circular motion, the centripetal force required for the circular motion is provided by the electrostatic force of attraction. Not a very important point, but nevertheless it is a point. Okay, so this is what is Rutherford's planetary model of an atom. Rutherford was the first one to say that, look, this is the nucleus, very, very small. Surrounding the nucleus, the electrons are revolving in circular objects. So these are electrons which are revolving in circular objects. Okay, the electrons are revolving in circular objects, in circular paths. Nucleus is at the center. Then electrons are revolving around it in circular paths. The nucleus is positively charged. The nucleus is positively charged. Not only is it positively charged, it contains all the all the charge and the mass, contains all the charge, contains all the mass of an atom. Okay, so this is what is Rutherford's planetary model of an atom. I hope this is understood. Yes, Rutherford said the electrons revolve in a circular path around the nucleus. Yes. Yes. Nucleus contains all the charge. Here is slide 8. Okay, now this is slide 9. Okay, so nucleus, NuCleus, no LeOUS, LeUS contains all the charge. Yeah, Rutherford said the electrons revolve in a circular path around the nucleus, NuCleus, no OS. Okay, so this was the planetary model of an atom. Now there were some objections to it. People said this can't be true. Why did they say this can't be true? They said this can't be true because of the work of another scientist by the name Maxwell. Okay, Maxwell, he demonstrated that accelerating electrons will release energy. Release means give out energy in the form of EM waves. Maxwell demonstrated that accelerating electrons will release energy in the form of EM waves. EM waves means electromagnetic waves. Okay, electromagnetic waves. Yeah, now what happens is this. Now the problem is, if electrons are moving in a circle, they are accelerating. Now if they are accelerating, then they must also be releasing energy. So if electrons are releasing energy, if electrons are liberating energy, they must be, if the electrons are liberating energy, they must be losing energy. If they are losing energy, that means their energy must be decreasing. So after some time it must become zero. Once it becomes zero, then the nucleus will eat it off. Why? Because nucleus is positively charged, it will pull the electron towards itself. Nucleus will gobble up the electrons. Yeah, but the electrons are still there rotating. It doesn't happen. So this was the prime objection given to Rutherford's model. Okay, the objection is that according to the scientist by the name Maxwell, he demonstrated that if something is accelerating, then that is, if something has a changing velocity, then it will release energy in the form of EM waves. EM waves are nothing but electromagnetic waves. Now if an electron is rotating around the nucleus, it is accelerating. If it is accelerating, then it must be liberating energy. So if it is liberating energy, they must be losing energy. Now, if they are losing energy, someday it will become zero. Once it becomes zero, the nucleus will catch it and pull it towards itself, right? But this does not happen. So they said, what you said is wrong. So they said, what you said is wrong. Okay, now do we understand this? Again shows 9th slide. I will. Sir, okay, sir, I will change the spelling. Sir, Max Planck is the student of Maxwell. Yes, Max Planck is the student of Maxwell. Neutron, Neutron. Okay. Where is it getting energy from? It is rotating. No, if it is rotating, it must be having some energy. If you are having if you are running around a particular thing, then you must be having some energy. Yes. Is Maxwell a physicist? Very good question. Yes, Maxwell is a physicist. Okay, can we move on? Okay, the objection is clear. Okay, then next is Rutherford student. Rutherford student is Niels Bohr. So Niels Bohr, Niels, Niels Bohr. So Niels Bohr is the next scientist. So this what we are now going to say happened around 1906 to 1910. Around this time Bohr came and then he gave his model of an atom. Okay, so I will write down the different points. We all have to understand. This is very, very, very important. Yeah. So first point, the nucleus which contains the nucleus, 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 contains all the positive charge and mass of an atom. Okay, then it is at the center of an atom. Okay, there is no change in this point. Yeah, then the second point, the electrons. Oh, you had asked for the 9th slide. Some error, 1 minute. You all wanted the 9th slide. Here is the 9th slide. Here is the 7th slide. Here is the 8th slide. Here is the 9th slide. Here is the 10th slide. Here is the 11th slide. Okay. Now the electrons revolve around the nucleus in fixed circular orbits. Okay, Bohr said the electrons revolve around the nucleus in fixed circular orbits. What do you mean by fixed circular orbits? So these orbits are fixed with respect to energy and another physical quantity called angular momentum. Okay, so now they are fixed with respect to energy and angular momentum. The electrons revolve around the nucleus in fixed circular orbits. What do you mean by fixed circular orbits? They are fixed with respect to their energy and angular momentum. Okay, then why did he say this? Because in Rutherford's model of an atom, they said that the energy will keep on decreasing. So Bohr said, look, I don't know why, but the energy will not decrease. Because he was not able to prove it, this is called a postulate. Because Bohr was not able to prove it, it is called a postulate. So this is a postulate. A postulate is a unproved statement made by a scientist in support of certain arguments. So this statement was there, he had no proof that look, energy won't reduce, because Maxwell said, and we rejected the previous model because energy is changing means it will collapse. But now this is what happened. He said, look, I don't know, but its energy won't reduce. Okay, I'll be back in a minute. Does Bohr get Nobel Prize out of 20? What is this out of 20? Yes, he got a Nobel Prize, but I don't understand this out of 20. Yes, in spinning tops, there is angular momentum, not just spinning tops. In anything rotating, there is angular momentum. When you try to rotate about your toes, in certain dance moves, they rotate about your toes. So when you rotate about your toes, you have angular momentum. Yeah, okay. Yes, 20 persons, not more than 20 people have got Nobel Prize. Yes, Bohr was also one of them. In fact, Bohr was the leader of all of them. Yeah, okay, second point is over. Now the third point. So the third point is the centripetal force required for the circular motion is provided by the electrostatic force. The centripetal force required for the circular motion is provided by the electrostatic force of attraction. Okay, is provided for by the electrostatic force of attraction. So what he said, one, this is the nucleus, the electrons revolve around it in fixed circular orbits. Then he called these orbits, he named these orbits. So we will write down fourth. Each orbit is associated with a number called its principal quantum number. Okay, each orbit or shell is associated with a number called the principal quantum, QUANTUM, quantum number. So the first shell he gave a number 1, second shell he gave a number 2, third shell he gave a number 3, 4, 5, 6 and so on. The first shell is also referred to as the K shell. The second one is also referred to L shell. The third one is referred to as M shell, N shell and so on. Yeah. So if you can make a note of this point, I will go to the next statement. And then he said, first one he called the K shell, second one he called the L shell, third one he called the M, fourth one he called the N, fifth one he called the O, and then he went this way. K, L, M, N, O, P, Q, R, S, T, like that. You don't need so many elements are not there, but this is how he named the shells. And each shell had a number associated with it. Okay. Then the next point is the maximum number of electrons in any shell is given by 2n square. This is the n value. So 2n square. So in this 2 electrons, in this 2 into 4, 8 electrons, in this 2 into 9, 18 electrons, in this 32 electrons, in this 50 and so on. This refers to the maximum number of electrons possible in any shell is given by the 2n square rule. Okay, this is the maximum number. He didn't say that so many electrons will be there. He just said that is the maximum number of electrons. Sorry. Sorry, 1 minute. Why did Bohr start naming from K, L, M, N instead of starting from A, B, C, D? A, B, C, D was being used by, A, B, C, D was being used by too many people. Okay, because A, B, C, D was being used by too many people, he started from K, L, M, N, O, P. Yeah. Number of electrons found is 2n square rule. Okay, I will show you. So there are two types of microscope. One is electron regular microscope. Yes. Okay, let's move on. Yeah. So this is the one, last one. You want the previous one? Yeah. The centripetal force. Now what is the centripetal force? Whenever any object moves in a circle, there has to be a force acting towards the center. That force which is acting towards the center is called the centripetal force. Yeah, whenever any body, suppose you take a stone and then you tie it to a string and you move it in a circle, you will see that you will be exerting a force. So now you have to exert a force, and that force you will have to actually pull the string. Now that pulling force which acts towards the center is called the centripetal force. Now you see nucleus is positively charged, the electron is negatively charged, so there is an attraction between them, so that is towards the center. So that force is what provides the centripetal force. Okay, so centripetal force, meaning of centri is center, petal towards the center. Centripetal force is a force which acts towards the center. Okay, in this case the electrostatic force provides for the centripetal force. Yeah, then he started naming it from KLMN. Mostly A, B, C, D are being used at many places. A for alpha, B for beta. So all those are also numerals which are being used at many places. So he said, okay, let me start from K. And then he started from K, L, M, N, O, and so on. Okay, then he said the maximum number of electrons in any shell is given by the 2n square rule, where n is the shell number. So in the fourth shell, 2 into 4 square. 2 into 4 square is how much? 16. 16 into 2 is how much? 32. So in the fourth shell, there will be 32 electrons. Okay, so this is Bohr's model of an atom. Yeah. Now I'll just quickly see if there are any questions, and then is it a formula? Yes, it is a formula. Sir, used because there were alphabets which were not used by any scientist? Not necessarily. I'm just giving you some answer. No, I have not thought about the answer for that. I'm just giving you probably because they were not used by any other scientist. Yes, 2n squared said by Bohr in arrangement of L. It's not actually just Bohr. It is actually called Bohr-Bury's. There was another scientist by the name Bury, Bhury. So they together gave this particular model. Okay. Yeah. So please understand that it is not just one person who is doing it. There are many people involved in it. I am just telling you the essence of what it is. Yeah. Okay. So which number were we? Fourth is over. Principal. Okay. Then let us assume this is the fifth point. Okay. Now next point we will say sixth point is that the maximum number of electrons in the outermost shell, the maximum number of electrons in the outermost shell is 8. In some cases 2. Okay, the maximum number of electrons in the outermost shell is 8. In some cases 2. Okay, then he further said the maximum number of electrons in the penultimate shell. Penultimate means what? Ultimate. This is the ultimate shell. Penultimate means before ultimate, last but one. Okay, the maximum number of electrons in the penultimate shell is 18. Okay, so we go this way: 2, 8, 18, 32, 50, and so on. We are now going this way: 8, 18, 32, and so on. So the maximum number of electrons in the outermost shell is 8. The maximum number of electrons in the penultimate shell is 18. The maximum number of electrons in the penultimate shell is 32, and it keeps going back. So not only did he say this, he also said this. Okay, so the actual number of electrons in any orbit is going to be a combination of these. Yeah, the actual number of electrons in any orbit is going to be a combination. We will see that. We will do a lot of practical things and then we will see that. Okay, just 2-3 more points and then we will stop. Yeah, sixth is over. Then seventh we will write down. This is a very important part. As long as an electron remains in an orbit, it neither gains nor loses energy. Okay, then if you give it energy, it can jump from one shell or orbit to another. If you give it some energy, it can jump from one shell or orbit to another. Then it can come back. Giving back or liberating the same amount of energy. Okay, this point I will explain little bit more next time. As long as an electron remains in an orbit, it neither gains nor loses energy. If you give it energy, it can take a fixed amount of energy and jump to another level. Then from there it can come back to its original shell, liberating that same amount of energy. Okay, we will talk about this in the next class. Yeah, before that, let us write down hydrogen. This is the symbol for hydrogen. Hydrogen has atomic number. So we will write down atomic number is the number of electrons in an atom. Okay, that is also equal to the number of protons, because all atoms are neutral. All atoms are neutral. Number of electrons is equal to the number of protons present in the nucleus. We will make a note of it. Number of electrons is equal to number of protons. This is equal to the atomic number. This is equal to the atomic number. Okay, hydrogen is 1. So if it has 1 in the first orbit, that is in the k orbit, it will have 1 electron. Then next element is helium. Helium. So helium has atomic number 2. That means in the k orbit it will have 2 electrons. Next, lithium. 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 Your mobile batteries are made up of lithium. So 3. Now in the K shell, maximum is 2 electrons. So 2 will go there. Next, the third one will go to the L shell. Lithium. Then beryllium. These are the symbols of the elements. Beryllium. Beryllium. 4. So K will be 2, L will be 2. Beryllium. Boron. Boron. 5. So K will be 2, L will be 3. Because maximum number in the penultimate shell is going to be 8. So here, maximum number only in helium will be 2. Boron. Then carbon. 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 6 electrons. So in the K shell it will have 2, L shell it will have 4. Okay. So like this, we can keep filling up. Oh, so many already. Beryllium 4. Yeah, very good. Second slide. Yeah, lithium ion batteries. Boron. Is that why we don't feel a shock on touching random objects? Yes. Yes, because the number of protons is equal to lithium. Proton number is also called as mass number. Yes, number of electrons is equal to number of protons. Yes. Mass number is different. Atomic number is what I am telling. Mass number is different. Mass number is the total number of protons plus neutrons. By this time, Bohr did not know about mass number. They had not invented mass number by then. Mass number is equal to total number of protons plus neutrons. Okay, this is also called the total number of nucleons. Nucleons. Those particles which are inside the nucleus is called a nucleon. So mass number is the total number of nucleons. Atomic number is the total number of protons. Number of protons, which is equal to total number of electrons. Okay, total number of protons is equal to the total number of electrons. Yeah, so that is different, this is different. Now my dear friend, suppose there is an element, okay, so next we will continue, next class we will continue. Okay, okay, next class we will continue. If you want to see the slides, I will show you the slides, but I don't like it, but I will still show you the slides. First slide. Second slide. Third slide. Fourth slide. $15. Okay, then it's a 16. Then 17. Here is a homework for you. Can you write the electronic configuration of elements up to atomic number 40? Up to atomic number 40, you have to write. For example, calcium is 20, so you have to write 1, that is L2, sorry, K2, L8, Lm. M will also be 8, N will be 2, so 20. Yeah, so this is how it will come. Why? Because it cannot be M is equal to 10. Why? because if m is equal to 10, we have already seen maximum number of electrons in the outermost shell will be 8. So this is more than, then this won't be there. So then it will not be there. So what will happen? M will become 8, then n will become 2. So like this, you have to write the electronic configuration of elements up to 40. Okay. So please try to write it. We will work on this in the next class. Yeah. Okay. Once more I show. I already showed. Okay, 17th page I will show once more. Oh God. Which slide do you want, Vijay? 17th page I will show. I will show all the slides once again. Okay. 17. Okay, 17. Then 16. Then 15. Then 14. Then 13. Then 12. Eleven. 10. 9. 8. 7. 6. 5. 4. 3. 2. And 1. Okay. So I hope you are all done. I showed all the slides. Hey, Lakshan again, 16th one. Okay, 16th slide. Okay. 16th slide here. Okay, bye. See you guys again next week. Thank you. Thank you. Thank you. Okay. Okay. Good afternoon and bye.